Next one, find all the local maxima, local minima and saddle points of the function fxy is equal to 4xy minus x power 4 minus y power 4. Okay. So first of all, write the given function. The function is like this: fxy is equal to 4xy minus x power 4 minus y power 4. So next we have to find the partial derivatives fx. Fx means we have to differentiate the function f with respect to x partially, dou f by dou x. Okay. So dou f by dou x means, so here 4xy is the first term. So here it is partial derivative. So treat 4y as constant and we have to differentiate the function, the term x only. Derivative of x with respect to x is 1. So 4y into 1. Okay. So with respect to x, 4y can be treated as constant. Okay. So take it aside and we have to differentiate the term x only. So 4y into 1, 4y, and derivative of x power 4, which is equal to 4x cube, and with respect to x partially it is completely constant. So its derivative is 0. So totally this is 4y minus 4x cube. Okay. Next, fxx. So second order partial derivative with respect to x. Okay. So which is represented as dou square f by dou x square. Okay. So that means we have to differentiate dou f by dou x again with respect to x partially. Okay. So with respect to x 4y, it is completely constant. Its derivative is 0, and derivative of minus 4x cube. Minus 4 into derivative of x cube gives 3x square. So minus 4 into 3x square, which is equal to minus 12x square. Okay. Next we have to find fy. That means dou f by dou y. Okay. So here 4xy is the first term. So here it is partial derivative. So we have to treat 4x as constant. Okay. So treat 4x as constant and we have to differentiate y with respect to y. Derivative of y is 1. Okay. With respect to y, x power 4 is completely constant. And derivative of y power 4 is minus 4y cube. Okay. So it is equal to 4x minus 4y cube. Next we have to find fyy, that is equal to dou square f by dou y square. That means we have to differentiate this function again with respect to y. So with respect to y, 4x is constant. There is no y term here. So its derivative is 0. And derivative of minus 4y cube. Minus 4 into derivative of y cube gives 3y square. So which is equal to minus 12y square. Okay. Next we have to calculate fxy, which is equal to dou y of dou f by dou x. Fxy means like this: dou y of dou f by dou x. That means we have to differentiate this function with respect to y. Okay. So derivative of 4y. So 4 is constant. Derivative of y with respect to y means 1. And with respect to y, 4x cube is completely constant. So its derivative is 0. So totally fxy is equal to 4. Okay. Let us see continuation. Okay, continuation. Next we have to find the discriminant. Discriminant d is equal to fxx into fyy minus fxy whole square. Okay. So this value is called discriminant of the function. So fxx means minus 12x square. Fyy means minus 12y square. So minus into minus plus 12 12 144 x square into y square. So totally this is 144 x square y square minus fxy whole square. What is fxy? It is equal to 4. So 4 square means 16. So this is the value of discriminant. Next we have to find the critical points for which the function is maxima or minima. So for critical points, we take fx is equal to 0 and fy is also taken as 0. So what is fx? Fx means 4y minus 4x cube is equal to 0. 4y minus 4x cube is equal to 0. And for fy it is 4x minus 4y cube. 4x minus 4y cube is equal to 0. Okay. So 4y is equal to 4x cube. Transposing minus 4x cube to right side, it becomes plus 4 cancelled. Y is equal to x cube. And here transposing minus 4y cube to right side, it becomes plus. Cancel the like terms, we get x is equal to y cube. Okay. So by solving these two equations, we get the critical points. Let us see that. Okay, continuation. Y is equal to x cube, comma x is equal to y cube. So we have the equations like this. So x is equal to y cube. Take this equation. X is equal to y cube. Y means already we have x cube. So x cube whole cube. So x is equal to x power 9. Okay. So transposing x to right side, we get like this: x power 9 minus x is equal to 0. Take one x as common, we have x power 8 minus 1 is equal to 0. Therefore, the product is 0 means we take x is equal to 0 or x power 8 minus 1 is equal to 0. X power 8 minus 1. Okay. So here the possible values of this equation are x is equal to plus 1 and x is equal to minus 1. Both plus 1 and minus 1 are satisfied this equation. 1 power 8 means 1, 1 minus 1 means 0. Minus 1 whole power 8. Okay, minus 1 also satisfied this equation. Minus 1 whole power 8. So it is also plus 1. 1 minus 1 is equal to 0. Therefore, finally the values of x are 0, 1, minus 1. Okay. Therefore, x is equal to 0, 1, minus 1. For these values, we have to find the values of y. Here y is equal to x cube. If x is equal to 0, then y is equal to x cube. So x cube means 0 cube, which is also 0. So the first critical point is, let us say this is a 0 comma 0. And for x is equal to 1, y is equal to x cube we have. So 1 cube means it is also 1. So the second critical point is 1 comma 1. And for x is equal to minus 1, y is equal to minus 1 whole cube, which is also minus 1. Therefore, third critical point is minus 1 comma okay. At a is equal to 0 comma 0. First of all, we have to find the discriminant. The discriminant is like this: 144 x square y square minus 16. So x is equal to 0, y is equal to 0. So 144 into 0 into 0, totally this is equal to 0 minus 16, which is minus 16. Minus 16 means it is less than 0. Okay. So if discriminant is less than 0, then the point is said to be saddle point. Okay. Therefore, a 0 comma 0 is saddle point. Okay. Next we have to check B 1 comma 1. at B 1 comma 1. So first of all we have to find the value of discriminant. Discriminant is like this: 144 x square y square minus 16. So x is equal to 1, y is equal to 1. So x square means 1 only, y square means 1 only. 144 into 1 into 1, 144 minus 16. Okay. So which is equal to 128, which is greater than 0. So discriminant is greater than 0. Next we have to find the value of fxx. fxx means it is minus 12 x square. Okay. So minus 12, x means 1. Okay, x means 1, minus 12 into 1 square. So which is equal to minus 12, which is less than 0. Therefore discriminant is greater than 0 and fxx is less than 0. Therefore the function has local maxima. Okay, with this condition the function has local maxima at this point. Okay, therefore b 1 comma 1 is called point of local maxima. Therefore b 1 comma 1 is called point of local maxima. Okay, let us see continuation. Continuation. Next, at the point C minus 1 minus 1, at C minus 1 minus 1. So first of all calculate the value of D. The discriminant is 144 x square y square minus 16. So 144, x means minus 1 whole square, y is also minus 1 whole square minus 16. So minus 1 whole square is plus 1. So totally this is 144 minus 16, which is 128. Okay. So once again D is greater than 0. Okay. Next we have to calculate fxx at this point. So it is equal to minus 12x square minus 12 into x means minus 1 here, minus 1 whole square. So minus 1 whole square is plus 1, 1 into minus 12, minus 12. Okay. So minus 12 means it is less than 0. Okay. Therefore discriminant is greater than 0 and fxx is less than 0. Therefore this point is also said to have point of local maxima. Okay. Therefore C minus 1 is a point of local maxima. Okay. So finally zero is saddle point. 1 comma 1 and minus 1 comma minus 1 are both points of local maxima. Okay, that is the answer. Thank you.